Well, dear students, till now in thermodynamics I have told you how to calculate the work done by a thermal system or on thermal system. And I told you about the internal energy of thermal system. And I told you that thermal system, in thermal system the internal energy of system can be changed by giving heat to it or by doing work on it or by both the processes. Internal energy in case of thermal system is the sum of kinetic and potential energy of molecules of the system. If the system moves as a whole, that is not the internal energy, that is external kinetic energy. If we have some gas in a box and box is moved, the energy possessed by the movement of box is not the internal kinetic energy. The internal energy is the sum of kinetic and potential energy of molecules. And I told you in case of ideal gas, there is no force of attraction or repulsion between molecules. So, the internal energy is only the sum of kinetic energy, and which entirely depend upon temperature of the system. Now, first law of thermodynamics, people are very much afraid of it and its application also. This simple law, it is the restatement, or you can say simply statement of law of conservation of energy. Kepler first law is simply the statement of law of conservation of energy. So I told you that we can change the internal energy of a thermal system by doing work on it or by giving heat to it. So what is first law of thermodynamics saying? According to this law, I am writing a simple statement. According to this law, when a certain amount of heat, say Q, is given to a thermodynamic system, then this energy may change the internal energy and then this energy may change the internal energies of system, energy of system, and system may use it to do work during expansion. That's all. You can state other way also, when certain amount of heat given to a system, then system expands it in raising energy and doing work against external pressure or anything during expansion. So, if on giving heat Q, heat Q to the system, delta U be the change in energy and W be the work done by system. After taking heat, then Q is equal to delta U plus W. Actually, here the change may be uniform when we give heat to thermal system, then temperature may rise, which volume may expand, and all these changes may be uniformly done or non-uniformly. In case of non-uniform motion, we take the instantaneous value. So, if at any instant heat given is dq, for dq means a small amount of heat given and a small interval of time, dq, comma du be the change in internal energy and dW be the work done. Then first law of thermodynamics can be written as dq is equal to du plus dw, or du is equal to du is equal to dq minus dw. Now we have to think how the heat is given, what process has been adopted. So many things are there and which are called state variables. Sometimes we don't allow the system to expand. And you know, dW I told you is equal to PdV. dV the increase in volume or decrease in volume at pressure P. These du, dw we use here for instantaneous, at any time, at any place. Just like we have told you average speed delta x upon delta t. But for instantaneous speed we write dx upon dt, that way. So du can be as dq minus p del dv. du the small change in the energy on giving small amount of heat dq. During expansion small change volume take place. If dv 0, then p dv is no work done, then d is equal to dq, and the total energy given is converted to heat. So total energy given converted to change in energy. Yeah, change energy equal to heat given. While using this equation, we have to use same unit of all quantity. Actually, sometimes heat is given in calorie. If pressure is Newton per meter square, volume in meter cube, then P delta P dV will be in joule. So, है ना? And dq generally given calorie, but you know 1 calorie is equal to 4.18 joule. So use all these quantities in same units while applying first law. While applying first law, I have told you work done is positive if system expand, volume increase होता है. If volume increases, work done positive. If volume decreases, work done negative, means work is done on the system. So while using this, we use convention, sign convention here. Sign convention. Heat given to system. Heat given to system is taken positive. Dear friend, don't afraid of this. For learner, everything is difficult. So don't feel that we are not able. Please read, do the thing, learn the thing very carefully and slowly. Learning is very slow process. Heat given to system is taken positive, and heat taken from system is taken negative. It is very simple. When we are heating water, we are giving heat. So that heat given to water is taken positive. When water is cooling, then temperature rise, decreasing, then heat is given by water out, and that will be negative. Number 2, work done. Work done by the system is positive, while work done on the system negative. Please be very calm and quiet while learning the things. Learning comes only when your mind is totally involved in the topics which you are reading and trying to learn. This law is a simple law. This is, I told you, the statement of law of conservation energy. I have read the notes given by teacher also. They simply tell it is the statement of law of energy and further forget where we are using. So we are using it in case of thermal system, and state that if we give some heat to a thermal system, then this heat may be used up in doing work and in raising internal energy. Simply remember that dq is equal to du plus w. du plus w. Now how the work done and how to change the energy, that is another thing. I told you in case of ideal gas, internal energy totally depend upon temperature. So if temperature changes, internal energy will change. We have learned specific heat, latent heat, etc. So when you are given heat, temperature rises system, and the heat required to raise temperature of 1 gram mass or 1 mole of substance by 1 degree centigrade. So that heat given is equal to, if volume does not change, so that heat given is equal to internal energy. So when we give heat to any system, actually we have learned thermal expansion also. When we raise temperature, volume increases, and in increasing volume, actually volume increase will take place against external pressure, like we are here in the atmosphere. So atmosphere pressure is there, due to which a force, certain force act normally on it. So against that force work is done. If there is no expansion, then total amount of heat given only used in raising internal energy. तो इंटरनल एनर्जी फिर मैं बता रहा हूँ, आई एम टेलिंग अगेन, इट इज द टोटल एनर्जी, काइनेटिक एंड पोटेंशियल एनर्जी ऑफ मॉलिक्यूल ऑफ सिस्टम. बल्क सब्सटेंस, लाइक सपोज यू हैव स्टील बॉल ऑफ 100 ग्राम, तो उस इंटरनल एनर्जी ऑफ दैट स्टील बॉल इज सम ऑफ काइनेटिक एनर्जी एंड पोटेंशियल एनर्जी ऑफ द atoms of iron ball. I hope you have got it. Now I will take in next video application of first law of thermodynamics. Thank you.